Pod-based e-cigarettes cause mitochondrial dysfunction, eventual lung injury. Electronic cigarettes use is increasing in Western populations, notably among middle school and high school students. As respiratory illnesses linked to vaping have emerged, some states have banned sales of flavored electronic cigarettes, in some cases making an exception for tobacco flavors. The health effects of these kinds of cigarettes remain unclear. Researchers recently explored the impacts of pod-based electronic cigarette flavors, hypothesizing that they would decrease mitochondrial function and induce mitochondrial superoxide production. The results were published online as part of the ATS 2020 International Conference. The researchers measured mitochondrial oxidation phosphorylation in lung epithelial cells on seahorse plates, which were exposed to either air or pod-based e-cigarette aerosols 3 times for 30 minutes each. Mitochondrial respiration with the cell mito stress test kit using the Seahorse XFP analyzer was measured immediately following and 1 day after exposure. Mitochondrial superoxide production was also measured, with the cells again exposed to either air or pod-based electronic cigarette aerosols in 3 30-minute sessions. Cells were measured 6 hours following the final exposure by flow cytometry with the Guava Millipore EasySight instrument. Right after the last exposure to dual menthol aerosol compared with air controls, the cells presented a significant increase in non-mitochondrial oxygen consumption. The dual menthol aerosol exposed cells also had decreased coupling efficiency compared with air controls. 1 day after the final dual menthol aerosol exposure, compared with air controls, a significant increase in non-mitochondrial oxygen consumption was observed, as well as a significant decrease in basal respiration. The dual menthol aerosol exposed cells also presented an increase in mitosocs, high and annexin V low cell populations, and a decrease in mitosocs low and annexin V low cell populations when compared with air controls. The researchers concluded that these results may indicate that prolonged exposure to pod-based electronic cigarette may result in lung injury due to this mitochondrial dysfunction.